Hi, I'm Kim Ha, and I'm from Block PK. This is our project for Engiana, and this is about concentration pattern. Lisa is asked to conduct an experiment in their chemistry subject. The experiment involves two tanks which are initially filled with 12 gallons of water. At the start of the experiment, brine solution with a concentration of 0.6 pounds per gallon is poured into the first tank at 1.2 gallons per minute. The mixture then enters the second tank at the same rate. The mixture is thoroughly stirred in the process of the experiment. A. Show the amount of salt in the second tank as a function of time. B. How much salt can be found on the first tank after 25 minutes? C. What will be the concentration of the brine in the second tank after 50 minutes?
Hi, I'm Heisen Sanchez, and I'm here to tell you about the proper approach on how to solve this particular type of chemical solution problem. Okay, so before we solve the problem, I'm just gonna help you further understand its concepts, and I'll show you how to check your answer. Let's name this tank Tank 1 and this tank Tank 2. Now it says here that both of the tanks are initially filled with 12 gallons of water. If we establish that Q out of tank 1 is equal to the Q in of tank 2, you will see that V is always going to be constant. Because Q in of 1 is 1.2, which is equal to the Q in of 2, which is 1.2. Q in Q out of 1 is equal. Q in Q out of 2 are also equal. So the V in each tank will remain 12 gallons at all times. Brine solution enters here and it gets thoroughly mixed in tank 1. It then leaves tank 1 and proceeds to tank 2. So the concentration leaving tank 1 must be the concentration entering tank 2. You can express this in equation by C out of tank 1 equals C in of tank 2. The concentration in tank 2 must be less than the concentration in tank 1. Why? Because before it enters tank 2, it gets thoroughly mixed in tank 1, making it less concentrated. This is one way to check your answer. The amount of salt in tank 2 at any time must be less than the amount of salt in tank 1 at the same time.
Hi, I'm Heisen Sanchez and I'm here to present the complete solution.
For the first tank, the initial volume is 12 gallons. The rate at which the solution enters and leaves the tank are the same, which is 1.2 gallons per minute. The salt concentration of the solution entering the tank is 0.6 pounds per gallon. Let X denote the amount of salt. So, the concentration of the solution leaving the tank is X over 12. Since this is a chemical solution problem, we use this equation. Plug in the given, we will have the following equation. We can solve this equation using variable separable, isolating x and t to both sides. And after getting the integral, we get solve for x using algebra. At time t is equal to 0, x is equal to 0. We now have the amount of salt as a function of time t. Substitute x to x over 12 to obtain the salt concentration of the solution leaving the tank. For the second tank, the initial volume is 12 gallons. The rate at which the solution enters and leaves the tank is just the same, which is 1.2 gallons per minute. We've established earlier that the salt concentration leaving tank 1 is equal to the salt concentration entering tank 2. And the concentration out of the second tank will be the mass over the volume, which is x over 12. Again, use the equation for the chemical solution. Then solve using linear differential equation. At time t is equal to 0, x is equal to 0. So, c is equal to negative 7.2. Plug in c to the equation of x, we now have the answer for letter A. For letter B, substitute 25 to t in this equation. For letter C, just substitute 50 to t in this equation.